Good afternoon. My name is Galdo, and today I will be presenting my project from the data mining seminar, Dropout Prediction in Massive Open Online Courses. My supervisor is Mikola Piccinski. During today's presentation, I will do a brief introduction on what mocks are and how they are usually structured. Also, I will present their main problem and a brief analysis about it. Then, in the literature analysis, I focus on papers that have worked in a similar topic and in the results. In the question proposal, I present the question that I tried to answer during the seminar, and then in methodology and results, I show the approach that I follow with the results I achieve. Last, I present the conclusion about my project. What are MOOCs? Well, they are massive open online courses. They are characterized for having a big quantity of users from all over the world, and usually they are free. They were born in 2008, but it was not until 2012 when the big boom happened, when platforms such as Coursera, Udacity, or edX created associations with top universities to offer their courses on the internet. But what is the problem of MOOCs? Well, a lot of people sign up for MOOCs, but only a few of them actually finish them, between 5% and 10% of the people. There has been some analysis about the possible reasons of dropout. It can be lack of interest. A person just signs up because MOOCs are the new thing, but they are not really interested in the course. Lack of time, because the course ends up taking more time than expected. Or lack of knowledge. These courses do not require, in order to access them, background knowledge, but once you start them, you might see that it was necessary. Also, these courses allow students to start later than the original starting date, but a lot of times these students feel like they are behind the rest and end up dropping it. Also, another reason for dropout is the bad course structure. Some courses have a big part of them are based on peer reviews, and there has been proof that there are bad practitioners doing bad reviews in this kind of structure. So actually, the kind of courses with peer review only have around 2% of completion. So during literature analysis, we will analyze 5 different approaches, all done over the same data set, which is a Coursera course whose format availability is in SQL and JSON. This course took 19 weeks, and all the projects try to predict dropout within a week. This means that at the end of a given week, they will be able to predict which persons will drop the course during the following week. There are different reasons. Each of them consider dropout a different thing. Some of them define dropout as a person that does not take a mandatory quiz during 1 week, and others that a person does not access at all the course. Some other people only consider dropout when that person stops accessing the course for the rest of its duration and not just for a given week, etc. All the methods presented here follow the definition of not accessing the course anymore, except one of them, which I will mention later. The first presented approach is a graph approach. They extracted features from the given dataset, such as video and forum information. Video information is playing or stopping the video, going forward, going backwards, and forum is related to the posts posted on the forum. So their intention is to represent this information using graphs. The nodes will be activities, and the edges will be activities transitions. Their intention is to use the graph properties in order to improve the performance of an SVM classifier. These properties can be such as density, strong connected components, central activity and transition, etc. They prove that using the graph properties gives a better performance than just using an approach without these properties. Another approach is random forest. They extracted features and they assign weights to them. 2 of the features with the biggest weight are total time invested in the course during a given week, or the scores achieved in each of the activities that were performed. This is the approach that only analyzes dropout for a given week. So this means that a person might drop out during the following week, but might be back in the course 2 weeks later. And they also did some interesting observations. It's not only important to focus on the accuracy of the model, but also, for example, in other metrics such as true positive rate and true negative rate. Because, for example, if given 100 students, 90 of them drop the course, it would be really easy to make a model where there is actually a 90% of accuracy, because you could predict that everybody was going to drop the course and the accuracy would be 90%. Another approach is SVM. They extracted features per week and per user. In total, 19 different attributes such as requests, page views per session, most active day, etc. And they use this information for prediction. But up to week 12 of the course, they use all the available data until the week that they were predicting in order to make this prediction. But from week 13 until the end, week 19, they discovered that it was better to just use the information from the current week and not from past weeks. Another SVM approach did something different to all the others. They classified the state of a student in active, inactive, and drop. Active is someone that actually is in the course. Drop, that he dropped the course and informed the system about it. And inactive are those that are still on the course but they don't access it anymore. They also divided the features into groups, activity related and quiz related, with the intention of then analyzing which one was more important at the time of classifying. They did different kinds of training, and they came out that the best model was the one where inactive users were included in the training data, and then they were labeled as active. They got a good performance, but it's important to say that from my point of view, when we're talking about inactive users, even if they have not informed the course that they are dropping it, if they are not accessing it, they should be considered as dropped out. The last approach is neural network with sentiment analysis. In this case, they also extracted features per user and per week, such as clicks, study sessions, course pages viewed, etc. And they also decided to apply sentiment analysis on forum posts. Actually, less than 10% of people usually comment on the forums of mocks. So it's not too big how much the performance of the model can increase using sentiment analysis. Still, they got a 2% increment in the accuracy using it. And they also use another metric to measure the performance of the neural network, the Cohen's kappa value, which is a metric that works really well with unbalanced data, which is the case. Here we have a comparison between the values obtained in the models mentioned before, and it's like accuracy, false negative, and ratio, and kappa. Best accuracy does not imply the best model for what I have explained previously, so it's also important to check the false negative rate value as well as the Cohen's kappa. Here, one of the models previously described is not included, since they calculated the accuracy for every week, and it was hard to summarize in this table. So, based in this literature analysis and the problem statement, I decided to come up with the following question proposal. I wanted to predict dropout with 1 week of an advance, so that organizers would have enough time to contact students to encourage them to continue. And my intention was also to achieve better results than the previous attempts, and using neural networks. One of my ideas was to, apart from predicting dropout, was also to predict the reason of dropout, so organizers would have more data at the time of contacting the students that were willing to drop out. But given the data set of information that I had available, this task was impossible to achieve. So, what was the methodology I followed? Well, in this section, I will present the objective, I will present a data analysis based on the data set, and how that data was transformed so that it could be fitted into a neural network, which I will explain its implementation and how I did the training and testing parts. So, as I said before, my objective is to predict dropout with 1 week of advance. I will need to develop one neural network for each week, since each week will have a different number of input variables. The input variables will have like a stable number, but then each week one more variable will be added that includes the dropout from that given week. So let's analyze the course, where the course started at the end of November 2014 and finished at the beginning of January 2015, taking in total 6 weeks. 16,224 students participated on it, and only 2,113 finished it, which represents almost 15% of the total students. The course was organized the following way. It had 2 introductory lessons and 6 lectures divided in several sections, making a total of 50. 1 lecture was given every week, and it had a mandatory quiz attached to it, whose deadline was the end of the week. Also, there is a tool quiz and a final quiz whose deadline was the same one as for the quiz of the last week of the course. We had different information. First, information regarding the students, and then information regarding the different activities that the students perform, events. In the case of student information, we have the achievement level, which represents the level that the student acquire at the end of the course. This can be none, absent, normal, or distinct. Normal is in case the student has passed the course, and distinct in case it has passed it with a really good grade. Absent, we assume that is when the student drops out and informs the system, and none when it doesn't finish it, but it doesn't inform the system about the dropout. Then we have one ID that identifies each user, and then some information such as age, continent, country birth, and country residence. This information, these last 4 variables, were not included in the neural network since in most of the cases it was empty. Regarding the event information, we have 3 different kinds of activities: lecture, quiz deadline, and quiz. We will only focus on the timestamp of the lectures and the quiz deadlines, but in the case of the quizzes, we will focus on the timestamp and the score acquired on it. Sadly, we don't have the starting timestamp and the finishing timestamp, only the starting one. So when a user performs activities such as viewing a lecture, we don't know if he viewed it for 1 second, 2 minutes, or 1 hour. So how was this data represented in a way that it could be passed as an input to a neural network? Well, to do this task, SQL was used, and the objective was to represent the data in a matrix in a numerical matrix that could be passed as an input for the neural network. One matrix had to be constructed for every week, and it contained the number of times lectures have been accessed until the end of the given week, and the scores of the different taken quizzes up to the end of the week, -1 in case that test had not been taken. And every week that was over would include the dropout of the students from that given week. It's important to mention that the weekly quizzes had 2 possible submissions, while the tool quiz and the final quiz only had 1 final submission. So in total, a neural network would have at least 66 input variables, 52 corresponding to lectures and 14 corresponding to quizzes, 12 from the weekly quizzes and 2 from the tool quiz and final quiz. So how did I implement the neural network? Well, I used Python version 3 and I used the library Keras. And the model of the neural network was a sequential model. This means that layers are added in the model until the expected outcome is achieved. In my case, it was enough with 3 layers. I had an input layer, which corresponded of 12 neurons and whose activation function was ReLU. I had a hidden layer, which was composed of n neurons. N represents the number of input variables into the neural network. Also, the activation function was a ReLU. The output layer had only 1 neuron, and the activation function was sigmoid. Why is it sigmoid? Well, its value is going to be between 0 and 1, which makes it easier at the time of mapping it to a 0 or to a 1. 1 will mean that the student will continue in the course, and 1 will mean that the student will drop out the course, and 0 that it will continue. In order to round it, in order to get 1 or 0, the values were rounded. So how was the neural network trained or tested? Well, in these cases where the data is so unbalanced, it's really important that when the division is made, both parts have still a distribution similar to the original one. So for this is used the stratify split. I split 75% of the data for training and 25% for testing. In the case of training, I use cross-validation. I decided to divide the data in 3 parts. What does this mean? Well, in cross-validation, when the data is divided in n parts, n-1 parts will be used for training and 1 part will be used for testing. And there will be a loop where all the parts become at some point the testing data. It is to check the performance of a neural network when there is not too much training data available. In this case, we can see in the image the different accuracy on average that was achieved in each week during the training. But of course, it's not only important to know the accuracy reached during the training, but also the one reached during the testing, when the data that is passed as an input to the neural network has never been there before. And we have it here. As in the cases I presented in the literature analysis, I focus also on the accuracy, false negative ratio, and kappa. Because every week we have more data available from each student, it makes sense that the performance of the neural network improves during the weeks of the course. So at the beginning, for week 2, we have, for example, an 88% of accuracy, 0.64 of kappa, and like a false negative rate of approximately 5%. And at the end, we are only in a 1.3%. We reach a 97% of accuracy, and the kappa value is in 0.89. So based on these results, and comparing it to the results that I saw during the literature analysis, even though it's important to say that they were 2 different data sets, and of course it's hard to make a comparison, it looks like a neural network with a similar structure to the one that I presented before is a correct approach to deal with dropout prediction in mocks. It would be necessary to test it with courses with similar structures, which I tried, but it was impossible to find these kinds of data sets. Based on my project, I would say that the important points at the time of predicting dropout would be that in case a neural network is being used, it's really important to prepare well the input of it, and it's really important to take care of getting to the correct structure of the neural network and to train it the correct way. Thank you very much. This is everything. If you have any questions, don't just contact me in this email and I will answer them as fast as I can. Thank you very much.